So one way of interpreting your presence watching this video is that you want to be a power user of Dynochem, and that means you should be ready to hear about the reference item in the ribbon. So whenever you're in a Dynochem model and all of these items are lit up in the ribbon, the reference item is available to you, either to draw the kind of cartoon or process scheme or rich picture that we often use when kind of conceptualizing what elements need to be in a model, what needs to be on the process tab. So I'll just mention that, but I won't open it. You can also access something called statements, and this is something which Dynochem power users like to do frequently. It is a cheat sheet. Anybody who's done a bit of video gaming will know what that means. It's a place where you can get lots of information about tips and tricks, ready-made little snippets of syntax that you can copy and paste into your model. So I'm going to just open statements really briefly so you can see what that's like. It's actually coming from the resources site. You can find it in the resources site too, but it's sometimes convenient to just get it from the ribbon. And in statements, when you enter statements, you can just press Control F. That'll bring up an Excel search. And if you search within the entire workbook, you can find all kinds of interesting things. I'm going to type impose here, just as an example of something that I might like to know more about. And I'm just going to hit Find Next. So it tells me that there is a whole section on imposed profiles, and then I can keep clicking next if I wish to go through the entire workbook and find out all about imposed profiles. These are profiles you can put on your data sheet, and they will actually override all other calculations that might be made for that particular response as your model executes. So lots of different places where imposed profiles are mentioned in the statements cheat sheet. If you don't want to do it by searching and clicking Find Next, just head back to the index in statements and click on the imposed profiles link. That will bring you to several fully worked out examples where imposed profiles are used. So lots of information here just about what we call the data sheet, and how it needs to be constructed, and the way in which you can impose and exert other forms of control over profiles that appear on the data sheet. So that's the statements cheat sheet. I'm just going to exit out of that. It's available from the reference item whenever you're in a Dynochem model. If you prefer reading material to kind of Excel content that you can copy and paste or browse through, then the manual could be a more interesting find for you. Of course, the manual cross-references statements because it's kind of easier to use some of the snippets in the manual if you get them from statements, but it has a detailed contents page and then hundreds of pages of documentation taking you through all the different ways in which the different statements you can include build up to make a fully fledged Dynochem model. So maybe I'll just look for imposed profiles again there in the manual. Imposing data profiles takes me down to a section that I can read about imposed profiles, and then there will be some further content illustrating ways in which to include imposed profiles, and then what that's going to look like when I go into the simulation environment. So again, I'm just going to close it. I'm not going to dwell there, but I just want you to see how from your model you can, with just one or two clicks, get at those two very useful resources for model building. So just to cap that off, what I'm going to do is impose a profile in our reaction model. And just to repeat what I said earlier, values that are imposed are going to take precedence over any other values provided for a variable. So it wouldn't be normal to impose solution reagent, much more normal to impose solution temperature. So you might want to say, look, I want the model to begin at, say, 20 degrees and then ramp to a higher temperature over a period of time. So you put the header at the top of the column, you write the word impose in this sort of header line for the data sheet, and then you indicate the values you want to use. So I'm going to say let's hold at 20 degrees for 30 minutes, and then let's ramp to, let's say, 80 degrees over the next 60 minutes, and then let's hold at 80 degrees until the end of the reaction. And that's going to just be applied right now to experiment 1. And I'm now going to press our familiar play button, the simulator icon, to get me out of Excel and into the model running environment. I'm going to choose experiment 1 again. And now for the first time in this series of videos, something is plotted before we press the play button, and it is this imposed profile we've just dictated. So now when I run this model, I'm going to right click and run. What's going to happen is any other provisions we made for calculating solution temperature are going to be superseded by the imposed profile, and the model is going to simply run at that temperature. But because we have an energy balance in the model is going to back calculate now what the jacket temperature would need to do in order to produce the pot temperature that we're seeing. So that's quite an interesting little back calculation there. Tells me I'm going to need to put the jacket on pretty aggressively to heat to 80 degrees over this period of time. But what's nice is I have rock solid control now over the actual process temperature, which is impacting my chemistry. I'm not leaving that to the whims of the temperature of my feed or the heat transfer capability of my reactor. I'm actually directly imposing that this will be the temperature for the reaction. And everything else that we've done before still works as before, including, for example, the calculation of yield. So we can see here now yield is 76.667% if we run with this different imposed profile. And what's also nice about this imposed profile is you can put your mouse pointer over the points in the profile, and you can move the points with your pointer. So you can come up with a different imposed profile that you would like the reaction to follow, and just explore how these different profiles might impact the chemistry. Now right now I think I've just done a pretty unusual profile: hold, heat, and then heat some more. But just for the purposes of power user training, I'm okay with that. I'm just going to press the play button. I think it had very little effect on the yield, but it did affect the jacket profile, for example, that we would need to accomplish this this imposed profile. I do have quite a lot of profiles on screen right now, apologies for that, but it is getting to be quite an interesting and complex model. But I'm now going to just change the chemistry a little bit so we can see an effect of imposing the profile. And I'm going to mimic a quite typical situation where the activation energy of the side reaction is higher than the activation energy of the main reaction. So this would tend to result in higher temperatures giving more impurity. So I'm just going to kind of illustrate that to you briefly. So now we have a 72% yield for our desired product with this imposed profile that I just created. I'm going to revert that to my 80 degrees heat up that I had earlier. I'm going to turn on ghost lines. Yes, that's going to mean a lot of curves, but I'm just going to try and make the point. We can now see that, yeah, taking us up to that high temperature sooner is actually quite bad for this chemistry. it's going to favor the side reaction. So the kind of imposed profile we actually need is going to be something much milder. I'm just going to try and carefully catch the points and take us down to a more moderate set of temperatures. So heating from 20 to 38 now. Again, I'm just doing this for power users so you can see the effect. And now when I run at this colder temperature, I'm back up to the 77, 78 in terms of yield percentage. Again, this model is calculating all of those kind of complex interactions, but now with that extra bit of control for me, the user, over the temperature profile during my reaction. And that's really imposed profiles, and one quite common way in which they can be used.